Okay, transistor is out and I have connected it to my semiconductor component analyzer, and let's see what my component tester is telling us. So I start testing, he's analyzing, and yeah, so that is what we already know. Short circuit, oh, he's switching off once again. Short circuit on red and blue. Also, that means red and blue is exactly what we found in the middle. So that is the collector, and that is the base, and the blue is the emitter. I hope I did it right way around. Anyway, doesn't matter. Yeah, the transistor is dead. It is ERF 2030, and yeah, I now will contact the old man who is owning this radio, and well, check with him what he wants to do. But yeah, we need, by the way, we need to replace both. You never should only replace one. Even the second is good, so it is good to replace everything, and therefore we have to order both, and we have to replace it, and then we have to adjust the bias for the final and as well for the driver, and yeah, therefore that will be the next when we have installed the new transistors to the radio. Then we have to do all the adjustment, bias setting, and so on and so forth, and yeah, then we will hope that the radio will work again. And of course, the ERF 2030 is not a bipolar transistor. It is a MOSFET version. So yeah, so this transistor does not have a base, collector and emitter, so that was wrong. But if I see the schematic, you can clearly see in here that we have a bipolar transistor in the final stage, and it should be a 2SC1969. So how can it be? Very simple. So that is the circuit of 2004, and there is a modification, ultrafos in 2011, and if we switch to the new schematic from 2011, you can find now the ERF 2030, and of course this is now a MOSFET final stage, so they have changed the complete final stage in 2011, and that is the reason why I made the assumption that this is a bipolar transistor, but it is wrong. So therefore we need two new ERF 2030 to replace the both final transistors in the radio. Finally, the new MOSFET transistors have already arrived, or finally arrived. So it took a while because I have ordered them in the United States. And the funny thing is, I was able to buy this Tranis overseas much cheaper than here in Europe. So yeah, that is really funny. But anyway, the Tranis are available, and now we can start our repair. Okay, so that is the package with the two new Tranis. Next is to take the second transistor out of the radio and replace this both with the new one. And then yeah, let's see if the radio will work again. But yeah, additionally to that, we have to align the bias after that, after the replacing, and these are the bias pots for both finals, so you can find them in the schematic down here for the first, and for the second one we have the bias adjustment here. You know, it is a little bit tricky because we only have one supply chain, and we have to place an amp meter in here, and the service manual is telling us that both transistors need each a bias current of 50 milliamps, right? So that means we have to place an amp meter in here, and we have to adjust both bias points, and that is a little bit tricky because both Tranis are connected to the same line, and if we have to, or if we want to do this alignment in a right way, we need to do one after the other. So that means we have to completely put one pot 100% counterclock wise. Then we have to align the first for 50 milliamps, and then after that we have to align the second one again for 50, but this is now additionally to our first 50 milliamp, right? So this must be on the right value first with 50 milliamps, and then again or additionally to that also 50 milliamps, means altogether we have to align it for 100 milliamps. And that is a little bit tricky because there are different procedures described in the service manuals, and some of them telling us we should measure the voltage at this point, and we should adjust it to something around 2.5 volt, whatever, and we should do it here and there. So we just and only control the voltage, but this would not balance the difference between the both trannies, because we can't be sure that the trannies are 100% matched, and if they are not matched, then this alignment description, which is also seen in original manufacturer's service manual, is critical. Because if you both put on 2.5 volt, for instance, then you do not really know what the result on the different trannies are. So with 2.5 volt, for instance, this tranny could already have a bias of, let me say, 60 or 70 milliamps, and the second one with 2.5 with 2.5 volts could only be at 40 milliamps. So from my point of view, this is not a good procedure to align this dual final stage, and especially on SSB, you should really have a good aligned final stage, and therefore I will show you the second way to bring both trannies on 50 milliamps, and then we could measure at the end the voltage at the recommended points to see what the voltage is in reality. And if the voltage is different, then that is a clear indication that the trannies are not matched. So that as side information to this issue. Okay, the old ones are out, and here are the new guys. And so we have a code on here on both of them, which are identical, and that should tell us that they are out of the same batch. And that should or will tell us that they are electrical wise somewhat identically. Well, let's check a bit if that is true. So we take the first one, and we put it to our analyzer. Okay, so that will take a while. Okay, and now we're gonna analyze, so we can see the display. And yes, it is a MOSFET. And what we can see is a VGS of 3.07 volt with 2.5 milliamps test current. And yeah, let's see if we find the same value for gate source voltage on the second transistor, or if there is a difference. Okay, so let's take this one off, and we put the second one in place. Okay, so now it is in place, and we're gonna start analyzing the second one. And yeah, it's a MOSFET as well. And what you can see here, it is only VGS of 3.05 with 2.5 milliamps test current. So, you know, that means there is a little difference between this both trannies, even they have the same data on the front, and this could lead to what I have told you before, that this could result in a different bias current if we do not really perform an accurate bias current setting. So that is really important. Okay, before we go and reinstall the new trannies, which have to come down here, we want to check the power supply circuit. So that is, you know, the big tranny which is down here, which we know already, and that is a guy where we had the burnt trace. So this tranny has not only one function. This tranny is responsible for the power supply of the pre-final and the final, and it is as well for AM the modulation amplifier. So we have really two functions. So that is this guy, and yeah, it is first of all directly connected to our power source, and secondly, if we follow this trace down here, and let me move up here, and you can see this trace which come from this tranny is supplying our finals. Okay, yeah, so that is the voltage, the current supply for the final and for the pre-final. So that is what you can see here. But that is not the only task this guy has down here. So as I said, it is also the AM modulator amplifier. So yeah, it has to do two things, and we can check it before we do anything else. Let's check. So for AM, so radio is switched to AM, right? And AM, we measure a voltage at 7.5 volt. So that is the regulated voltage towards the final and the pre-final. Okay, and when I switch it to let's say SSB upper sideband, you can find, I check the same voltage again, and now we have nearly our supply voltage. So on SSB, this tranny is not for modulation. So on SSB it is only the power supply for final and pre-final, and the same when I switch it to FM, right? On FM the modulation is working as well in a different way, and it is also nearly the supply voltage from the power supply, right? So only on AM, so let's go back to AM, right? We have at this point 7.5 volt, and that is right, because you know that is the adjustment for the swing we need on AM, and now we know the switching between SSB, FM and AM is working, so we have a change in our supply voltage. And secondly, we can now check if the audio is available, and therefore I take my oscilloscope and I'm connecting it to the radio, and yeah, we will do the same. It is switched to AM, and we will see if we push the PTT and talk, if we can then see audio. Okay, again, oscilloscope is now connected to the tranny, and oscilloscope is connected, and radio is switched to AM, right? And now what we want to check is if we can see audio on this test point, and therefore I push the button here, and we will see what we find on the oscilloscope. Okay, so that is what you see. 1, 2, 3, test. 1, 2, 1, 2, 3, 1, 2, 3, test. This is an audio test. Audio, audio. 1, 2, 3, 4. Okay, so what does that mean? The power supply is working perfect, so we can be sure that everything is okay. So we have seen the different voltage in the different modes, so that is telling us that the switching and the regulation is working as it should. And secondly, on AM the oscilloscope is reporting audio. So that means now we can be sure that our circuit down here is working perfect, because all these transistors here around this power transistor are responsible for switching the different modes, right? So switching for SSB, for FM and for AM, and as we have seen, for the different modes we need different voltages that the radio will work at the end. And the result of this test is that the power supply is okay, and we do not need to think about is something wrong in the power supply, does the power supply directly destroy our new final stage. So if final stage will be destroyed, it is not due to a faulty power supply. So that is really telling us a lot. And this kind of circuitry is used in many newer radios from the early 2000 up to now. A lot of radios are using this schematics, this circuitry for doing regulation, switching, and amplitude modulation, amplification. So that is what this circuitry is doing, and now we know this is perfectly working. So new final stage is in. Very important is to fasten these screws with force, that they are really connected to the heatsink, because otherwise they would die very fast, because the heat can't go away. So therefore take care on that. And the solder work is already done, and board is already cleaned, so that is okay. Yeah, that means we can start with the bias alignment. Okay, so let's start with the bias adjustment, and I have already connected the amp meter, DC amp meter, to the preamp, and the preamp should have 50 milliamp in upper sideband, so it is switched to upper sideband, and power is completely on high power, but mic gain is completely closed, and under this condition we should reach 50 milliamps when we key the PTT. So if I key the PTT right now, you can read we have 31 milliamps. What we want is 50, and 50 milliamps can be adjusted with a pot down there, and therefore I take my alignment screwdriver, put it in, and now I key already the PTT, and now I'm adjusting. Okay, so 50 milliamps. So 50 milliamps. So let me adjust it a little bit lower. A little bit, not much, but just a little bit. So when it heats up, that there's a little bit margin. So yeah, okay, leave it at 48.9. So that is close enough. So that is really close enough. So that is bias for the pre-final. Okay, so the pre-driver adjustment is done, so that is really nice. Now we need to switch over to the final. So this here is the final, and let's key it as well. Yeah, so that looks pretty nice. I have closed this both pots nearly to 0, and as I told you before, we need to adjust first one and then the second one. The first should reach 50, and then additional to that we should reach 100. But these pots are really not very nice to adjust, so they are known for that. So therefore that could be a little bit tricky, but let's check. Okay, so I've already pushed the PTT, and I start with the first one, and wow, you see, that is what I meant. So we need to be really carefully. So we are now, so that is already too much. So that is what I said. So you need to be very carefully while adjusting this bias, but you know, yeah, it is a bit difficult to do it with the camera in hand, but anyway, we need to get it as close as possible. Yeah, 48. We need a bit more, just a bit. 49. So you see what I meant. So you need patience when you do such an alignment. You see, that was already a bit too much. So it is not good to be too high. So that is not very clever. Okay, so it is really difficult on the camera. So let me do it off the camera, and I show you the result. So so that is the first tranny. So 49 is pretty nice. 48, 49, switch off. PTT 48. So that is pretty nice for the first tranny. And now, in addition to that, I have to adjust the second one. You can see it is closed completely, and this is now already adjusted. So that is what you can hopefully see. Now we go for this one, and now we should have together nearly 100. Okay, both together 100 milliamps. So that is what we want to see. That means now our pre-final and our both finals are adjusted to the values we are looking for. So therefore the adjustment has been done, and yeah, let's go and check if we have now output power. So this current PCB is now back in place, and it is soldered so that we have good contacts for final and pre-final. So everything is in place, and now we want to see if the radio is producing RF. Okay, so it is on upper sideband, and mic is fully clockwise, so that means it is open. And okay, so let's check. Hola. Hola. Audio. So, what you can see is the radio is producing RF. So that is 30 watts. 30 watts. Yeah, so we are pushing for 30 watts TX, and yeah, here you can see the needle is working, and we are drawing 5.7 amps. So yeah, the transmitter and the radio all in all is working. Everything is good. So that means the repair is done. Everything is perfect, and yeah, I have to assemble it back, and then radio goes back to the owner. Okay, so that's the repair so far. Everything is okay, and all the critical things have been done, especially the bias adjustment. So don't change simply your driver or your driver or your final without performing a bias adjustment, because you can simply kill your new transistors. So be careful. That is essential if you have such a problem. And yeah, I now go and assemble the radio back, and then yeah, ready. So that's it. Hope you enjoyed it a bit, and yeah, catch you next time. Bye.